Hi, and welcome to our video tutorial lessons at Gleaming Moon School, Omaha. This is Mrs. Edith Igweyoma's tutor. This lesson is called SFO2, Whole Numbers and Decimals. We'll be learning about whole numbers and decimals, and this is one of the lessons in our series of lessons in standard form. For this lesson, you will only be needing your exercise book, your pen, and your pencil. I want you to pay attention and follow every instruction that I give you. Practice the things you learn over and over and over, watching the video and completing the quiz. And in no time, I bet you will become a master of mathematics. Okay, this is a very short video, which is concentrated on identifying and comparing whole numbers. So our objective is going to be to understand, to differentiate, and write whole numbers and decimals. And the processes we're going to go through in doing that would be: one, we're going to start by understanding what decimals are, what are they, how are they written, how do you know them? And then we identify decimals, differentiate them from whole numbers, and then we order decimals. Now, we've got three numbers here. What type of numbers are these? I want you to have a think. Absolutely. We have 23, which is a whole number. We have 2.3, which is a decimal, and we have 2/3, and that's a fraction. For the purpose of this lesson, we will be focusing on whole number and decimal. Fraction we'll be dealing with on a different platform when we look at decimals, fractions, and percentages. Okay, so in order to look at whole numbers and decimals, let's start with the number 12. So let's say we have 12 sweets and we want to divide those 12 sweets, or we want to share those 12 sweets among 3 people. So that means we're going to have groups of 3 for those 12 sweets. So the first person is going to get 4 sweets, the second person will get another 4, and the third person will get another 4. So 12 divided by 3 would give us 4. Now 12 divided by 4, again, we're sharing the 12 sweets among 4 people. So the first person gets 3 sweets, the second person 3, third person 3, and the fourth person 3. So 12 divided by 4 gives us what? 3. Now remember, these 3 sweets are whole sweets, okay? They're getting 3 whole sweets. All right. Now we want to divide that 12 again by 2. So there are 2 people, me and my friend, we want to share 12 sweets. So I'm going to get 6 sweets, and my friend will get 6 sweets. So 12 divided by 2 is going to give us 6. On the other way, if there are 6 people sharing 12 sweets, each of them is going to get what? The first person will get 2, second person 2, third person 2, fourth person 2, fifth person 2, and sixth person 2. So each of those 6 people are going to get 6 whole sweets. Okay, 2 whole sweets, not 6. Right. How about if there were 5 of us sharing 12 sweets? So let's see how that goes. So first of all, the first person gets 2 sweets, the second person gets 2 sweets, the third person, the fourth person, and the fifth person. Now let's check and see if we have shared all 12 sweets. So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our sweets haven't finished. We still have 2 sweets left. So if we want to share those sweets, so let's go back again to the first person. We give the first person 1, and we give the second person 1. And that makes 12. There are still 3 people out of us all who haven't got any share. Have we all shared the sweets equally? No. So what do we do with these 2 sweets that are remaining? Okay, so we have 2 sweets left here. What do we do? Okay, so we take those 2. Now let's say in real terms there are 5 of you and you've got 12 sweets. You've shared the first 10. Everybody has gotten 2 each, and there are 2 left. What do we normally do? We break that 2 down, don't we? So if this, for example, let me use this now. So if this was the sweet, so we have 2 of them here. What do we normally do with these sweets? We will split them up, won't we? Split them up, break them up, break them up. Okay, So we get different pieces of this sweet, all right? The same thing we've done here, we do the same to this sweet. And we get different pieces, and then we now share those pieces equally among 5 of us. So that means each person is going to get 2 whole sweet and some other pieces of sweets that are not up to 1 whole. And that is what we do when we are doing division. Now remember, if you're doing 12 divided by 5, so let's have a look. Let's use the long division method. Let me clean this off. Okay, so we are using our division, long division. So I have this for my long division. Okay, and then I have 12 in here. How do I get that down? Okay, font, yep, 36, let's get it down. Okay, so I have 12 there, right? And then here, I want to divide that 12 by 5. So there are 5 of us, and we are sharing 12 sweets, okay? So first of all, we share the first 10, right? And we get 2. We've got 2, all right? And 2 times 5. Now, the way we do it, we do 12 divided by 5, right? Which is 2. 2 times 5 is what? 10, right? So we write 10 below 12. And then what do? We divide them, right? Okay. Not divide, we subtract them. So 12 minus 10 is going to give you what? 2, right? So you have 2. Now you can see, and this 2 is my remaining 2 here. Okay. This is my remaining 2. That's the 2 I have here. Now the question is, what do I do with that 2? I have explained to you in real terms, you have 12 whole sweets. We've shared it. Everybody has 2 whole sweets each, and we have 2 sweets remaining. What we do is to break that 2 sweets into pieces of sweets, right? And then share that pieces. Now that pieces we are sharing is not a whole. Even though someone might get up to 4 pieces, that still does not amount to 1 whole sweet. So that is exactly what we do here when we do this division. So we've got 2 here. 5 cannot divide 2 because 5 is more than 2. So what do we do there? We come back to what we've written here and we put a decimal point, which means it's no longer up to 1 whole. That's what that decimal point is telling us. It's telling us that it's no longer up to 1 whole. By the time we share that 2, it is no longer up to 1 whole. So we put a decimal point and then we come back to these 2 and then we add a 0. So that makes it what? 20. And now we can divide that 20 by 4. So it's just like when we have split those 2 remaining sweets into different pieces. So now we have 20 pieces. So we can share these 20 pieces among the 5 of us. And you know that 5 can divide 20 to give us how many? 4. And that makes our answer here to be what? 2.4. So that 4 there, 0.4 there means it's a fraction. It means it's a part of a whole. It is not up to whole. So that makes 12 divided by 5 to be equal to what? 2.4. So now looking at this 2.4 in comparison to these answers we have got here, we've got 4 whole, 3 whole, 6 whole, and 2 whole. Whereas here we have 2 whole and 4 parts of a whole. Okay, so you can see the difference between the whole number and the decimal. The decimal shows up that there are some parts that are not up to a whole. Now let's move on. Okay. Now, when we talk about decimals, there are 3 key information we need to know about decimals. So I would suggest you pause the video after I've shown you this and write that down in your book because you will be needing those information. Number 1, any number that has a decimal point is a decimal number. Okay. And then number 2, on a decimal number, the digits to the right-hand side of the decimal point are less than 1. Remember the 2.4 that we have? that 0.4 is on the right hand side of the decimal number, and you know that is less than 1. It is not up to 1 whole suite. Okay, and then the third one, the digits to the left of the decimal point are greater than 1, just like the 2 that we have in our 2.4. So let's have an example. 2.317. You can see that you have 317. There are 3-digit numbers here. Okay, but then this whole number, all these numbers from the decimal point towards the right are what? Less than 1. There's just no two ways about it. They are not up to 1. So those remaining 2 suites, we can decide to split it into so many pieces, hundreds of pieces. It is still not up to 1 whole suite by the time we share it. Okay, so that is basically what this is telling us about. Whereas the 2 whole here and whatever other number that may come on this side towards the left hand side is what? Greater than 1. So always bear that in mind when you're thinking about decimal numbers. Now let's look at more practical examples. So we have 1.2, 2.3, 0.5, 2.0. Now for 1.2, you can see the 1 part is what? 1 whole. So this one tells us that it is 1 whole. And then the 2 tells us that there are 2 parts. Okay. And then here, 2 tells us it is 2 wholes, and 3 tells us that this is a part. So there are 3 parts to that. Now coming to 0.5, the 0 means what? No whole. There is no whole number. So that means, and then the 5 there tells us it is a part. So having no whole and a part means this number is less than 1. Okay, the first one we looked at here has 1 whole and 2 parts. Here has no whole and 5 parts. So that means it is less than 1. That 5 parts is not up to 1. And then here we have 2.0. The 2 tells us there are 2 wholes, and the 0 tells us there is no part. So if there is no part, that means this number is a whole number. So this number is exactly the same as if you just wrote 2. So in other words, you could say that to make a whole number look like a decimal, you add a decimal point and add a 0. Okay, you put a decimal point at the end and add a 0. And that tells us something very important about whole numbers. So at whole numbers, number 1, they can be written with a decimal point followed by a 0. For example, you have 3.0, 1.0. Okay, and then number 2, they can have many zeros after the decimal point. Those zeros are called placeholder. I will talk about placeholder later on in the video. So for example, if we have 3.00000, it doesn't matter how many zeros you put at the end, it is still number 3. 1.0000, it doesn't matter the number of zeros you put there, it is still number 1. Okay. All right. Now let's do some practice. I'm going to ask you to pause the video, okay, and answer this question by yourself. It says, indicate whole numbers with W and decimals with D. So there are 9 questions here. So I want you to show which ones are whole numbers by putting a W next to them and which ones are decimals by putting a D next to them. Okay, off you go. All right, now let's have a look at the answers. Okay, how many of you got it right? Give yourself ticks for the ones you got right. And then the ones you didn't get right, pay attention to my explanation. Okay, so we have 0.02. Now, remember I told you that a decimal means there is a part that is not up to a whole. So here, we have no whole is less than 1, but then there is a part to it. Okay, and so because there is a part to it, this means it's a decimal number. Here, we have a whole, and we also have a part. this is a decimal number. Here we have a whole, but there is no part. So this is as good as number 1, and that makes it a whole number. Number 4 has a part as well, and a whole number, which is a decimal. This has a part and a whole number, which is a decimal. This one already is written as a whole number. There is even no placeholder with 0 there. So it's just a whole number. And if you look at number 7, you will find that number 7 is exactly the same thing as number 6. We only just put a decimal point and the 0 placeholder to make it have 1 decimal place. So this is just a whole number with no parts. So that makes it a whole number. This one again has a part, although it doesn't have a whole, but it is a decimal because it has a part that is not up to a whole. And number 9 has a part and a whole. Okay, let's move on. Now, we're going to look at ordering decimals. How do we order decimals? So let's begin with this number 10. So there are 5 of us, and we want to share 10 sweets. I love sweets, so I'm going to use sweets so much in my explanations. So there are 10 sweets, and there are 5 of us sharing 10 sweets. This is dead easy, isn't it? Because 5 goes into 10 and there is no remainder. So 10 divided by 5. It's just going to give us 2. Each person will get 2 sweets, and that's 2. Now, if we increase the number of 6 to 11, and it's still 5 of us sharing 11 sweets, what do you think is going to happen? We will get 2 sweets each, but how many will remain? 1. So that gives us 2 remaining 1. Now, if we have 2 remainder 1, like I showed you when you're doing your long division, that 1 that is remaining, we have to split it, don't we? We have to split it in order to get the decimal parts, to get the parts that we can share. Okay, so now because we are dealing with numbers in base 10, we always deal with numbers in base 10 anyway, but that is why these numbers are divided by tens. So we're gonna divide that 1 by 10 to get its value. Or let me put it this way, we have 1 sweet remaining, so we need to split it. So to split it, what do? We put a decimal point after our 2. So for example, let me put it this way. So we have, I'll just use this one as the example and then I will talk the rest through. Okay, so we have 11, okay, and we are dividing it by 5, right? Okay, so 11 divided by 5, and already we've gotten our 2. Okay, and that 2 is remaining 1. The same way we do our division, 2 times 5 will give us what? 10. So if we have 10 there, we now do what? We subtract, don't we? We subtract. So if we do 11 minus 10, what are we going to get? We're going to get 1. And that is the 1 that we have remaining here. So that's this 1 that is remaining here. That's the 1 we have here. Okay, so now because we have this 1, what do? We add 0 to that 1, and then to our 2 here, we put a decimal point, which means we are now going to split 1 whole. It's no longer going to be a whole. But then we've got 10 here. 5 divided that 10 is going to give us what? Another 2. So that gives us 2.2 as the answer. So 2 remaining 1, we just add decimal point after our 2 whole. This is the 2 whole that we've gotten. Okay, so let me make it clear here. This is the 2 whole that we have got from dividing our 10. Okay, so that's 2 whole. Okay, so we have the 2 whole there, and it's remaining 1. So with this 1 remaining, we put a decimal point there. Okay, and then add 0 to this one to make it 10. So if we add 0 to this one to make it 10, so we add 0 there. Don't mind my squiggly 0, but you know what I'm saying. We add 0 there to make it 10, and then 5 divides that 10 to give us what? This 2 here. That gives us this 2 here. Okay, so in the same way, if we increase the number of sweets to 12, okay, and we want to share 12, so remember it's still 5 of us, our number hasn't increased, so it is still the same 5 people that are sharing these sweets. So we have 12 sweets shared by 5 people. Now what are we going to have? We are still going to have our 2. Last time 1 was remaining. This time how many is going to remain? Exactly 2. So we will have 2 remaining 2. And if we have 2 remaining 2, the same thing we did last time, we write our 2 whole, put a decimal point, and put a 0 in front of these 2 to make it 20. And 5 goes into 20 how many times? 4 times. And that would give us 2.4. Let's keep going. We increase our sweet to 13. And it's still 5 of us sharing that number of sweets. So again, we will still get our 2 whole each. But how many is going to remain now? Last time we had 1 and then 2. So now how many is going to remain? 3. So if we have 2 remaining 3, again, we write our 2 whole, put the decimal point, add 0 in front of 3. That makes it what? 30. And how many times does 5 go into 30? That is 6 times. So that would give us what? 2.6. Now, we increase our number of sweets, this time 14 sweets, 5 of us sharing it again. So we're going to have how many remaining? 4 remaining. And then if we put our decimal 2 whole, decimal point, add 0 in front of 4 to make it 40, 5 goes into 48 times, so we will have 2.8. And then if we increase again, now remember, we have had 1 remaining here, and we've had 2 remaining here. Okay, so we've had 1 remaining, 2 remaining, and then we've had 3 remaining, and now we've got 4 remaining. So if we are sharing 15 sweets, how many is going to remain? I can hear someone saying 5 is remaining. But if 5 is remaining, come to think about it, how many are we? There are 5 of us. So if 5 is remaining, that means we can share them and get 1 whole each. So in addition to our 2 wholes, plus the extra 1 whole that we're going to get from that 5 that is remaining, we're going to have how many each? 3. And nothing will remain. So 15 divided by 5 is going to give us what? 3. Now, if you have a look at this, you will notice that there is a pattern that has been formed here. Okay? From the number of sweets that we are sharing, we started from 10 and increased the number of sweets all the way to 15. So you can see our number of sweets gets what? Bigger. Now, in terms of the resulting decimals, the first one we started from 2 and it kept on increasing up until it gets to 3. So you can see that it also gets bigger as the number of sweets gets bigger. So in other words, you can say that these decimal numbers, for example, if you look at 10, here, come on, drawing board, okay. So if you look at 10 here, 10 and 12, which one is bigger? It's obvious, isn't it? 12 is bigger than 10, okay? And 13 is smaller than 15. So in the same way, looking at these resulting decimals here, you can see for sharing 10 sweets, we have a result of 2. And for sharing 12 sweets, we have a result of 2.4. And you will find that 2.4 is greater than 2. And in the same way, 2.6 for 13 sweets is less than 3. So can you see how these decimals can be compared alongside our whole numbers, which we already know how to compare? Okay, so if we say 2.5 in comparison to 2.3, how would you compare that? You will find that 2.5 is bigger than 2.3, and 2.3 is smaller than 2.5. Okay. Now, how do we compare decimals? Now, remember, when you're ordering decimals, you will compare them to know which one is bigger and which one is smaller. And it is from that comparison that you will be able to do what? Order them, either ordering them from starting from the smallest to the largest, or starting from the largest to the smallest. So now, this is what we call decimal comparison table. You use this table to compare decimals. I'm not going to dwell so much on this. I'm just using this for the purpose of this lesson. This will come in mostly by the time we do fractions, decimals, and percentages. That is where you will see a lot of this table being used to compare decimals, okay? All right, so now you remember your place values, because this is all about place value, the place and the value of every digit in any number that you are considering. Okay, we all know our place values, where you talk about 100, tens and unit, thousands, 10,000s, 100,000s, 1 million, and so on and so forth. So now this is your decimal point here. Okay, this is your decimal point. And on this side is your whole number. So this side is your whole number. And then this other side is your decimal. And remember, the decimal side is less than 1. So if you have 2 as a unit, 0.3. Now remember, after the decimal point, again, this is because we are dealing with numbers in base 10, because we always count in tens. That's why when we get to 10, when we get to 9, we do 10. And when we get to 19, we move up to 20. And when we get to 29, we move up to 30. 39, we move up to 40. That's because we are counting in tens. Okay? So, and because of that, after the decimal point, your first number after the decimal point is the 10th. You're now dividing by 10, is the 10th. So, and every other place after that would be in multiples of 10. So you have tenth, the next one is 100, the next one is 1,000, the next one would be 10,000, 100,000, and it will keep going on like that. There is no unit because these are less than 1. Okay, so, and one thing you need to know is that the numbers in the whole unit, side of the decimal, from here towards the left-hand side, you know that as the numbers get to the left-hand side, it gets bigger. So like here now, we have 2. As we move on to the next left-hand side, this number is 10. Is bigger than this 2 here. If we split them up, this 2 is just the unit, whereas this one is 10. 10 is bigger than 2. If we move further to the left, this number here, so I've said this one here is the 10th, is bigger than the unit. And if we move further to the left, this one here is 100 and is bigger than the 10 and is bigger than the unit. And as we again continue to move towards the left, the number keeps getting bigger. This one is also 100 and is, this one is also 1,000 and is bigger than 100 and is bigger than 10 and is bigger than unit, even though the digit here is 2 and the digit here is 1. But in terms of value, these ones have higher values than these 2, because they are going towards the left and the values increase as you go towards the left. So that is what I'm trying to explain here, that the number gets bigger as you move towards the left. Whereas after the decimal point, as you move towards the right, the number gets what? Smaller. Okay, so that means, what that means is that this 3 will be bigger than this 3. And this 3 will be bigger than this 3. And this one here is certainly bigger than this 3, even though this is 1, but that one 3. So that is how it works with decimal numbers. So with that, you know how you can compare and order your decimal numbers. So the 10th is the biggest, followed by the 100th, followed by the 1000th, followed by the 10,000 if you have one, 100,000, and so on and so forth. So it gets smaller as it goes towards the right-hand side, whereas in your whole number, the number gets bigger as you go towards the left-hand side. I hope you've understood that. So let's have a look at some example. Okay. So the question says, put these numbers in order, starting from the smallest. And we have 2.03, 2.30, 23.0, 2.003, 0.23. Okay, so we are asked to put this number in order, starting from the smallest. In other words, put it in ascending order. Now, I'm going to use my decimal comparison table to do this. Now, before you draw your decimal comparison table, there are things you need to consider. First of all, you need to consider your whole numbers. What is the highest value of the whole number? What's the highest digit value of the whole number? Basically, the question is, what's the highest number of digits you have for your whole number? Now, if you look at it, this one has 1 digit before the decimal point, so that's the unit. 1 digit before the decimal point, the unit. Here we have 2 digits, so that's tens and unit. Here we have 1 digit, unit, 1 digit, unit. So in our decimal comparison table, we just start from tens, unit, and then decimal point. So after the decimal point, what do we need? How many digits do we have? We can see that the highest number of digits after the decimal point is here, where we have 3 numbers. So we have 3 digits here after the decimal point. So that means we're going to need the 10th, the 100th, and the 1000th. So here is my comparison table. So I have my tens and unit, 10th, 100th, and 1000th. Now, starting from the first number, so what I'm going to do is any one I do, I will draw a cross around it to show that I've done it. So this is the first one. So for my first one, 2.03. So I'm going to write this 2 is 1 digit, so that means it will come under the unit. Okay, so you can see I have my 2 under the unit 0.03. And that 03 comes under the 10th, the 100th, and I stop there because that's where they follow. And now the next one, 2.30. Okay, I put it there again. 2 is 1 digit, so that's under unit 0.30. That's the 10th and the 100th. Okay, and then the next one, 23.0. You can see that's 2 digits, so I'm gonna end up with the 10th. So you can see 2 tenths, 3 units, 0.010. And the next one, 2.003. Again, I have 2 single digits, which is the unit, and then after the decimal point, I have 3, so that's 10th, 100th, and 1000th. And then for the last number, which is 0.23, I have 0.23. Now you can see that I have lined up my numbers. What I need to do now is to begin my comparison. Now, but before I begin my comparison, you can see that there are some blank spaces there that need to be filled up so that everything will actually align properly. And that is where the 0 placeholders come in. Okay, so you can see that this 2 is on its own here. I need to fill in these spaces and hold those places. So for holding these places, I'm going to need the number 0. Remember, 0 means nothing. So it just stays there just to stay in the place, but it doesn't count anything. Okay, so I'm going to fill up these places with the 0 placeholder. So I have my 0 there, I'm using a different color so we can identify the zero placeholders. They are not part of the numbers we are comparing. We are just using them to hold the places so it will be easy for us to see what we are doing and be able to do the comparison properly. So we have 0 there, the next 0, the next one, the next one, the next one, next, 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 and next. So you can see it all makes a perfect picture. Now you can see everything with the zero placeholders in place. Now, how do we begin the comparison? Now let's have a look. Remember, tens is more than units because as you go towards the left in the whole number, the number increases. But as you go towards the right in the decimal part, the number gets smaller. So 10 is the highest value here. So, and this number that has 2 tens, that means this is going to be the highest number, okay? This is going to be the highest number that's going to come last in our list. So we need to find the smallest number. So we finished with tens. No other number has any digit for tens. It's only this one. Now coming to units, we have 2 units, 2 units, and 2 units. This is 0 units. So that means this number here is less than 1. So if this number here is less than 1, there is no other number that is less than 1. So that makes this number our smallest number. So I'm going to label it 1. Okay, so this is our smallest number. So since it says put the number in order starting from the smallest, this is going to be the first in our order. So what's going to be the next number? Now let's see. The remaining 3 numbers, because already we have marked this one as our highest number. So this one is going to come last. This is the highest number. But then we have 1, 2, and 3 remaining. And all these for the unit are the same. So if they are the same, we can't pick out the smallest from here, can we? No. So we move on to 10th. Now remember, 10th is the highest value after the decimal point. So, and under the 10th, we have 3. So that means this is going to be the next highest number, which is going to come before the 23 that we have chosen. So this is not the one we want. And there is no other number on the 10th. Already we have chosen this one as our first one. So we move on to the 100th. The 100th is the next highest number. So you can see we have 3 here. So that means this is not the next smallest. So the next one would be 3. Now, on the other hand, if we look at it from the decimal point, let's have a look here. You can see that after the decimal point, let's just pretend these are whole numbers. You will see that this one here is 300. And this one here is 30. Whereas this one is 3. That makes it absolutely clear for you to see which one's the largest. So you can see 300 is the largest, followed by 30 and 3. So that means 3 is the smallest. So in our ordering, this is number 1. Our number 2 number is going to be 2.003. So that's our number 2 number. Okay, so that's our number 2 number. Then the next one, we've seen 3, 30, 100. So the next one is going to be what? 30. So that's our number 3. Okay, so that's our number 3 number, 30. And then our number 4 number is going to be 300, 2.300. So that's number 4 number. Okay, and then that takes us to the one we have already identified as our largest number because it has the 10th value, which is the highest of all the values here. So this would be our number 5. So in that way, we can now write out the answer to this question, which is this. So you can see our number 1 number 0.23 is there as the first one because it says put these numbers in order starting from the smallest. So you start, this is the smallest, followed by this, followed by this, followed by this, and then this. If you were asked to put them in order starting from the biggest, you're going to go from here to 23.0 to 2.3 to 2.03 to 2.003 and then 0.23. So it's just the other way around. Okay. So you can see our first number 0.23 is there. Our second number 2.003 is there. Our third number 2.03 is there. And then our fourth number 2.30. Actually, this should be 30 looking at the question here. So forgive me. I'm going to put 0 there. 2.30. Let me see if I can make that 0 big and to commiserate with yep, let's see how we can make that big enough. Yep, there's it. 2.30. There we go. So 2.30 and then 23. Okay, so you can see that we have ordered our numbers. We don't need these blue zeros. They are just placeholders. They are not part of the numbers that we've been given. We only use them to be able to see what we are doing. Okay, now is your turn. Okay, what I would ask you to do before you try the next questions I'm going to give you, watch this part again, listen to my explanations, and try to understand what I have done before you move on to answering the next question. Okay, so here are the questions. Put these numbers in order starting from, so there are two ways that I have done that, starting from the smallest. So for these 1, 2, and 3 questions, you start from the smallest number and put them in order up to the largest. Whereas on the right-hand side here, you're starting from the largest number up down to the smallest. Okay, so I want you to pause the video and answer this question. Okay, let's have a look at the answer. Okay, how many of them did you get right? Give yourself a high five if you got them all right and give yourself some nice ticks. Okay, right, so let's have a look at number 1. We have 200. So apparently we will be starting with 100, and that's the highest whole number. There is no decimal point here, so this is purely a whole number. We also have another whole number here, which is 20, and then the next one we have 0.02 and 0.20, and then we have 2.00. Now if you have a look at these numbers, you see that I have 2 numbers here that are less than 1. Now the question is, which one is smaller? So if you have 0.02, remember the 10th is the first digit after the decimal point, and it is the highest digit after the decimal point. It is the highest value after the decimal point. So if we have 0.02 here, and then we have 0.20, you can see that the 10th is this one. 2 is the 10th, whereas the 10th for this one is 0. So that means this one is bigger than this one. So in order to do our selection, you will find that this one is number 1, the very smallest. So that's why we have it there as the smallest. Okay, where is my stamp? So that's where we have it there as the smallest. And if you look at this one, this is now the one that follows as the next smallest, which is what we have here as 0.20. Now the next one, obviously this is 20, so it's a big number. This is 200, even bigger, but this one is just 2.00. So that makes this our next number. Okay, so that makes this our next number here. Sorry about that. So that makes this our next number, 2.0. And then the next one is 20 and 200. Okay, if you look at number 2, again, we have 14.0. So 14 whole numbers. This is 141 whole numbers. This is just 1 whole. And this is 1,415 whole. And this one has no whole. So the smallest, obviously, is the one without a hole, followed by the one that has just 1 hole, followed by the 14 hole, and then 141, and then 1,415. Now looking at number 3, we have 1.0, 0.1, 0.01, 0.001, and 1.1. So we have 3 numbers here that are less than 1. Okay, now this one has the 10th as 1, so that's the highest value. This one has the 100, so we have the 10th and the 100. And this one has the 10th, the 100, and the 1000th. And remember, after the decimal point, as the number gets towards the right, it gets what? Smaller. So because it gets smaller as it gets towards the right, you will see that this one obviously is the smallest. So 0.001, which is 1,000th, is the smallest number here, followed by 100th, and then followed by 1/10th, and then followed by 1 unit, and then 1 unit with a part of 1/10. Can you see that? So this is 1.0 and then 1.1. Something extra has been added to this 1.1. Something extra has been added there on top of this 1.0. 1 part has been added. So that makes this one more than this. Remember when we looked at when we compared those decimals, when we are sharing sweets, 5 for 4, so we started by sharing 10 sweets, 11 sweets, 12 sweets. You saw how the parts kept on increasing, increasing. So that is what has happened here. The part from 1.0 has increased to 1.1. Okay, now here we are going from largest to smallest. So we'll begin with the largest number. So here we have 209 holes, 20 holes, 2 holes, 2,091 holes, and 0 holes. This one is very obvious. 2,091 is your first number in the order because that's the largest number, followed by 209, followed by 20, and then 2, and then 0. Okay, it doesn't matter what comes after the decimal point because the whole number parts have already compared themselves. We only look at the decimal parts if the whole number parts are the same. Okay, for example, let's jump to number 3 so I can explain this more. In number 3, we have 0, 0. So let me use my highlighter again. So we have 0, we have 0, we have 0, and another 0. Can you see that? So the whole number parts are the same, and because they are the same, we now turn to the decimal parts to see how we can compare them. So these are the decimal parts that we will use to do the comparison. Now remember, like I said before, in the decimal, after the decimal point, the first digit is the 10th value, and the 10th is the highest value. So you can see from here that out of all of them, this is the only one that has a value for the 10th, and it is even 9 for that matter. So for the value of that 9, okay, let me use this so we can see clearly what I want to do. So you can see that's the value 9 for the 10th. Okay, so that makes this one the highest for these 0 points. But already we have some whole numbers that are already pronounced. So you can see that 90, you can see that 90 is obviously bigger than 9. And that is why 90 is our first, followed by 9. And once we've got rid of those whole numbers, that is where this one now comes in 0.900, because that is the one that has the highest value, which is the 10th place value. So that's that one. And after the 10th, the next one is the 100th. Now you can see that this one has a 100th value, and this one also has a 100th value. But look at the digits. This one is 9. This one is 1. 9 and 1, which one is bigger? 9 obviously is bigger than 1, and that is why our next number is 0.090 followed by 0.01. So this one comes last because that is the thousandth, okay, and it is of lesser value than the hundredth and the tenth, and that's why it's the last. So we have ordered this starting from the largest to the second largest, third largest, fourth largest, fifth largest, and then the smallest. So going back to number 2 now, we have, looking at the whole numbers again, we have 17, 0, 0, 175, and 1. Which one is the largest? 175. And that is why is our first number, followed by 17, which is our second number. Remember, we are going from largest down to the smallest. So after 17, the next one we have would be 1. So that's the next largest. Now for the remaining 2, you can see that both of them are 0 and 0. So we go over to the numbers after the decimal point. And after the decimal point, like I've always said, the 10th is the first digit after the decimal point, and it has the highest value. So this one has 0/10, whereas this one has 1/10, and that makes it the next largest, which brings this one as the smallest. I hope I have explained this in a way that you will understand it. I would advise you, if you are not sure that you've understood it at this point, watch this video again, take the notes, try to do these questions by yourself, and then play again to check your answers and listen to my explanations. It will help you so much. Okay, so what have you learned? We've come to the end of this lesson. Like I said, this is a very short video. We are just looking at whole numbers and decimals. So I want you to show me what you've learned. Like I said, if you didn't understand it the first time you watched it, watch it again. Okay, watch it over and over. Try out the example questions that I gave on your own first, and then have a look at the answers that I provided. Listen to my explanations for the answers. It will go a very long way to help you understand what we are doing here. All right. So what I want you to do now is to complete the quiz for this lesson. This lesson again is called SFO2 Whole Numbers and Decimals. You will find the quiz on our WhatsApp group. Tell your parents. Your parents should be a member of the WhatsApp group. If your parents is not on the WhatsApp group, tell your parents to send his or her number to the admin, and the admin will add him onto the group. If he goes to the group, they will find a link to this video and to the quiz there. Also, if you go on our Facebook page, Gleaming Moon School, you will also find a link to the quiz. Alternatively, you can get in touch with the admin, and the admin will send you the quiz. So I want you to do the quiz because I will be watching out to see your responses in the quiz and see how you performed in the quiz. So complete the quiz. If you didn't get all the questions right, you can try again and again and again. The quiz allows you to try as many times as you like until you get them right, okay? Next lesson, our next lesson would be on SFO3, multiply by multiples of 10. We're going to be looking at how you multiply multiples of 10, or how you multiply numbers by multiples of 10. So I will see you then. Bye-bye.